Hello, my name is Adam Pease. I've been working for about the past 20 years on a large ontology called Sumo, and I want to give you an introduction today on what is an ontology. So ontology is all about shared meaning. It's about sharing meaning and understanding between computers and people, but also between computers without people in the loop. Communication is a challenging thing, even for people. If a person says to another person, I walked, that symbol, walked, has connotations associated with it. The person who's listening to that word knows all sorts of things about walking. He's seen walking, he's done walking, he's understood how people express themselves and what they mean by walking, a whole host of different things. But if a computer listens to the word walking at its most basic level, if it's got a microphone, all it's going to get is some kind of waveform. Maybe it gets it in text, okay, it gets those characters, but it doesn't really understand what those characters or that waveform means in any way the same that you and I understand what it means to walk from here to there. So all of these symbols that we use in communication, that we use effortlessly every day, are an index or a pointer to things that we know. And if we speak multiple languages, we may have multiple symbols for the same thing and understand them and understand when they're being used in these different contexts, whether it's the context of a different language or some other context that changes the meaning of that symbol. However, computers are dumb. They don't have any of this information. They can't speak English or any other language, really, any other human language, because they don't understand what's behind all of these symbols, what they mean. We can even see this, of course, with humans. I might say to another person, I see buffalo, and without clarification, we don't know whether you're talking about the animal, the buffalo, or Buffalo, New York. This in linguistics is known as word sense disambiguation. It's a common problem, and it's also quite a difficult problem. But at some level, it's easily solved if you can ask the original speaker, well, did you mean the city, or did you mean the animal? And then hopefully if they're interested in conversing with you, they'll clarify. But we don't have a way for machines to do that currently. We also see this in software. In software, you might have an equation like this, maybe in some Java code, y equals x plus s plus am, and you might assume, okay, this is some kind of numeric formula. But just change the variable names, and it all of a sudden acquires a completely different meaning. You can see that we're doing string concatenation with first and last names. Now, it's important to note that these two programs, at least these two lines of a larger program, will function in exactly the same way regardless of the names that you give these variables. The variables, their names are there, one, to be a unique symbol that the computer can keep track of, but really mainly for other programmers to be able to read the code. If you're a sort of a lazy programmer and you just have single character identifiers, then somebody reading your code is not going to get a lot of information about what you intended. If you write something like this instead, they're going to at least get a little bit more information. But still, the computer is going to have very little ability to understand what you mean. At least in modern programming languages, we have things like types, so we'd presumably defined these variables earlier and be able to say, oh, this is an integer or this is a string, but that's still not a lot of information. It would be much better if a computer could actually understand what's the format of a typical name in a typical cultural or linguistic context. That would allow the computer to do a lot better, to do a lot more to help us find problems statically in our code, as opposed to just finding them later on during testing, or worse yet, when deployed to a user. Another thing that modern programming languages have helped us to do is to have a library of things we've already said. So imagine you're writing some code, you need a stack data structure, and so you come up with your own stack and it looks like this. Well, we don't really know as users or visitors to this code, if we didn't write it, what was really intended. We can kind of guess. We know what stacks are, but we don't really know all the details about how it will behave. Whereas if we're competent Java coders and we're already familiar with the JDK, the Java software libraries, and we reuse something like the array data structure listed here, then we've got a source, and it's an authoritative source. We know that really good programmers wrote this and tested it, and there's a lot written about it, and you can find out all this characteristics. We don't have to just read the code for this particular class. We can actually read a lot of instructions and learn about it pretty quickly, and we know that it's probably been very well debugged. So reuse is really valuable. And this also holds true for ontology. So I would say that there are two requirements for building an ontology or having a good ontology. You want to be able to say everything you want to say. No one would write in a programming language these days that isn't Turing complete if they want to do general purpose programming. You wouldn't be able to handle having arbitrary restrictions on what you want to say. The same is true in a dictionary. If you were writing a dictionary and somebody said, well, your sentences can only be 5 words long, you'd have a pretty hard time as a dictionary writer. You also want to have said a lot of things already. So we might say that an ontology is like a dictionary for computers to read. And what are some characteristics about a good dictionary? A good dictionary is big. If somebody handed you a one single page and said, here's my dictionary, you'd laugh, because a dictionary that's only on one page isn't terribly useful if you're trying to have an authoritative source for general purpose communication about anything in the world. You'd also want it to be expressive. You wouldn't want to have a 4-word limit on definitions. You wouldn't want to have a limit on definitions that says, you couldn't have any sort of dependent clauses, or you couldn't have things like may or should or kind of that would qualify your statements. You'd want to be able to have the full expressive power of English or whatever other natural language you're working in. So I'd say a good ontology is both those things, but because we're talking about computers, there's an additional requirement. That dictionary is going to have to be in a formal language. If you just have a dictionary in English, computer really can't do a lot with it. Maybe you can do some interesting things in information retrieval, but it's not going to have a real deep understanding of what those words mean. They're still just going to be sort of characters that can be matched or indexed. So we want these three things. We want our ontology to be big. We want it to be written in a very expressive language, and we want it to be written in a very formal language so the computer can do computation with it. So that's my summary of what's an ontology and maybe a little more about what is a good ontology. And I hope you found this interesting. Thanks.